Welcome. And like 100 years ago, there was a huge revolution in the way the factory works, and we still bear the consequences of this change in how we do software development right now. So. Yeah, probably you have heard the story. Probably you know about Toyota. Probably you know about Lean. And still, I'm trying to figure out what is going on with this Lean thing, and how those company works, what works for them, what doesn't work for them. And one of the things I'm discovering is it sounds super simple, it's not super simple. So I will try to show you some of the ideas behind the Lean and how we translate this into the software development. So first of all, we start with this gentleman. You know the guy? Yeah, Henry Ford. Yeah, you guys good. Okay. So he has a pretty nice idea, and his idea is basically we can create repeatable parts, and we can create a car with these repeatable parts because it's super fast to assemble. So the idea is super simple. So what you do basically, you have a pretty expensive machine. Let me do it the right way. And it's gonna be easier less easier with this mic, but still. So what we do here is I have a pretty expensive machine for creating, let's say, doors, because this is what I know how to draw. These are doors, by the way, if you didn't notice. And I have John here, and this is John, and John will be doing doors. And the thing is if you have repeatable cars and you can create a lot of cars, then the super expensive machine can be used often, many times, and this leads you to lower costs. So basically, the more you produce, the better, because the price of one single item is lower. So basically, the mantra in Ford is basically produce more, which means that resource cannot be idle. We'll get back to this one soon. Now, what is happening, this idea was pretty great. And the thing is, if you would go in 1920s to US and you will look around and you see 3 cars, 2 of them would be Ford. So basically, no matter what you're trying to buy, it's gonna be Ford most likely, right? So he has a over 60% of the market. But the thing is, when the competition starts catching up, when the other companies joined the mass production, what they started to discover is we need to create different cars because people has different needs, and just one car, just one type of Ford doesn't work anymore. So they had to create different cars with using the same machine as we have here. Here's the little problem with this machine is because this machine cannot be idle. This resource cannot be idle. So anytime we switch the machine to produce a new types of parts, like for the different car, we need to stop the machine. And this is pretty expensive. So what we have here is something we call a transaction cost. So we basically pay for switching the machine. And we'd rather not to have switching of the machine because that's expensive. So what we do basically, we create a lot of large batches, which basically means we create a lot of doors for one car, then create a lot of other doors for other car, and so on, and so on, and so on. Now, the consequences of this one, Ford is losing market, and by the beginning of the Second World War, he has a 20% of the market. So imagine this one, he has a 2/3 of the market, and he end up with 1/5 of the market. A little small change in 20 years, right? Now, after Second World War, we go to Japan. We move to Japan, and there is this gentleman. How many people know this one? That's a great answer for the next question about this gentleman. I'm asking about this gentleman. So this is Kichiro Toyoda, the owner, the founder of the Toyota car manufacturing company. And he's struggling on his market. He has a way smaller market than in the US. People are expecting different kind of cars. So basically, you cannot copy the idea from Ford, because Ford is creating like 10,000 cars per month, and Toyota can create 900 cars per month. And again, those are different cars. So, you know, the idea is great, but it just doesn't work. And now, inside his company, we have this guy who is Tachio, no? It was just a few minutes ago. And he has some observations. So what he's observing is like, when we have our John, and he's creating a car, doors, and then we have, let's call him Stuart, and he's going to assemble those doors into the car. One interesting thing is happening. Because we are creating a lot of doors, it's super hard to put them in between those two guys. So you know what we need? We need to have a big warehouse. So we're going to store those doors into this warehouse. Now, of course, we need to have someone who will take care of the warehouse. And of course, we need to have someone who will take the doors from John to the warehouse. That's the more complicated part of the drawing. You can imagine that it's a man on a small car. And then I need another man who will take those doors later on to the place we're going to assemble them. And by the way, you know, this warehouse is pretty big, so you have a lot of parts inside, and you have a lot of things inside. What you need? Well, you need a software to manage all your inventory, right? So we need to have a software. Because this is a Japan company, let's call it with the Japan name, Godzilla. And you know, because we have a software for managing the inventory. Oh, yeah, so sorry about that. Godzilla, yeah, that's Godzilla. Because we have a software to manage inventory, you know what? You need to have someone who will be administrating the software for managing the inventory. Again, it's Japan, so let's call them a sumo master. So now, what else? Well, certainly some parts get stuck. So some cars, you know, people are expecting to get their cars, but no one is producing those cars because we are producing the different kinds of cars. So now we need someone who takes care that the parts are being pushed through the system. Well, let's add a few more people. Let's call them parts master. And now all the system is working, except that if you think about it from the customer perspective, like most of it is just a waste, right? If you think about this, like this guy doesn't have much value. This guy doesn't have much value. Well, the whole warehouse doesn't add much value. Neither this one, nor this one, nor this guy, nor this guy, nor this guy. So what is Tachio saying is like, if we have a system, then we end up with having like a little bit of, it's super hard to change all the colors, by the way. Value added into the system, but most of what we do into the system is basically producing waste. Now we know how to solve the problems. You know, that's the 1950s, 1960s. US or the West world, you know, discovered this in the 1980s. So the only thing we need to do, Tomek, now is just remove waste. That's super simple, right? Except it's not. So let me first move for a second into the software development. Let me show you something what is happening in the software development in the 1923, for example. So I have a developer, and you know he has in his fancy tool list of tasks to be done. Well, now I have a tester who is also busy with some other work. Now the developer is finishing his work. He's changing the status in the system. You know, he has a system, so he doesn't need to talk to the tester. That's super cool. So the item goes to the tester, and what the tester is doing? Well, it's not gonna test because he's busy with something else, right? So, basic, basically, I mean, he's finding bugs with something else. So, like 2 weeks later, the tester, opened the ticket, look at the ticket, read the ticket, and say, okay, let's try testing it. And he finds something and he sends it to the developer back, saying, hey, there's a bug in your software. And what is happening then? What is developer doing? Yeah, this one, he's busy with something else because, he has plenty of work to be done, right? So again, 2 weeks later, he opened the codes. That was a month after he wrote this code. So he has no idea what the code is all about. He has no idea that he wrote this code, basically, right? He read this code once again. He read the documentation, say, yeah, that was a typo, sorry about that. Send it to tester. What is tester doing? Something else. Whoopsie. That was control. Almost. So the tester is doing something else, and now 2 weeks later, the tester opened the bug and see, yeah, that's fixed the problem. So yeah, we can go production. And now something that should take like 2 days, 3 days total, it's taking us 6 weeks, and most of this is one testing. So just remove waste doesn't work in most companies. And what Toyota is discovering is like a three important items for you to take away. So one thing that to understand is that the waste is everywhere. So it's not easy. So I know that sounds super simple, but yeah, whatever. It took you 15 minutes to tell us that the waste is everywhere, right? But the thing is, like, most companies doesn't invest enough time into removing the waste. What Toyota is doing, they improve continuously, and by continuously doesn't mean, every 2 weeks we have a retrospection, or every 3 months we have a, meeting of all the managers to remove remove the problems. This is done on daily basis. So every day, if you go to Toyota factory, every day someone goes around on the Toyota factory, doing a tour on the Toyota factory, finding the waste. And if by accident you don't find any waste on your tour, you go back to your manager, take your manager by your hand, and you go once again, because it's not that there are no waste in the system, you just didn't notice them. So you are supposed to find the waste. And this is so much imprinted in Toyota that they are looking this continuously. Because the other thing that you will figure out soon is if you go to those people, so our sumo master, our part manager, or anyone else in our system, and they tell them, do you add a value to the customer? What are they going to say you? Yeah, sure, presently. I mean, you cannot fire me. I'm the most important person in this company. The warehouse is not going to work without me, right? It is super important to have our Gojira system up and running, right? We have 8,000 items in our Gojira, so, there is no way we can remove this one from the system. I mean, we cannot manage our requests from the customer other way, except for using our fancy software. So the other thing is waste looks like, value added, right? And most people will tell you, well, what I'm doing is value added. And going to some people and say, hey, you're adding waste into this component is not a very nice, polite way of doing this one, but this is what we're mostly doing. And this leads to the last point I want to show you here is like if you have waste, then most likely the waste is going to create more waste. Which basically means that if I have someone who is free, idle, and he's looking for something to do, then, maybe I have nothing important to do now, but, I cannot do anything because, remember, resource cannot be idle. So what you're going to do, basically, you will create some document and send it to someone else, and he needs to reply to you, and you create more documents, and you create more different stuff, more components, more artifacts, more parts of the system that no one cares about, and you end up with a lot of components in your system you have just created to keep people busy, right? So if your mantra is keep people busy, which is the mantra for most of the organization, then you're most likely going to create more and more waste. And I'm going to give you a story, a short story from outside the software development. A friend of ours is a lawyer. And she said, I used to work with one company, and basically that was like a, they paid me for an hour. So they were sending sometimes documents to me. I was checking this document, giving them feedback, sending them back. And they say, well, we need you so often that it's a good idea to have you full time. So she joined them full time, and soon as she figured out that they're sending to her every single potential document they have, just in case, So can you ask this? Can you check this one? Can you check this one? Can you check this one? All those documents, by the way, has way lower quality that they used to have. Surprise, surprise, because we have a resource free, so how about making her busy, right? And by the way, due to that, the time between we decide to sign the contract and we are able to sign the contracts was tremendously longer than it used to be. Surprise, surprise. Every single specialist will will increase the time you deliver anything into the market. So what we can do about it? Okay, so Tachiono is saying one thing. Tachiono was saying, change overproduction. So the idea of creating more and more and more because it's going to be cheaper, change it to waiting. Because you're going to see that people are waiting and doing nothing, so you can act and you remove the waste. Except that it's pretty hard to do in our context of software development. That's my observation. So my recommendation is to do one of two things. Well, one is make one piece flow through the system easier. And the second, surprise, surprise, make overproduction, so working on many items, harder. They may sound as the same one, but basically the first one means make cooperation easier, and the second says make lack of cooperation, creation of new items, creation of new backlog items, and all this stuff harder. Now, if you think about most of the companies, they do exactly the opposite. So go to any company, it's super simple to add anything to your backlog, but it's super complicated to remove anything from the backlog. Imagine that you go to your company and say, hey, tomorrow we're going to delay the whole backlog. What do you mean by delayed? Change the status of this one, archive this one? No, delayed, right? And now imagine that any stakeholders come to you with 10,000 new requirements, say, hey, that's a great idea for us, right? Super easy to add to your backlog, super difficult to remove from the backlog. The same with the project. It's mostly super easy to start with the new items in the backlog. Sorry, to start new project, you just find someone. Do you want to, fund my project? Do you want to find my? How about you gonna find my project, right? So you go around and find someone who's going to fund your project. Now try to finish this project. Try to cancel this project. Now it's way more difficult. So we get this kind of observation, we get this kind of behavior into the system. So giving you a few positive ones, so we not just keep to the negative one. Let's say if you think about this, how we make a cooperation easier on one item is like a cross-functional team. Make the cooperation easier, like a component teams make the cooperation harder because you focus on what you need to do, right? So that's a super easy concept. But the other concept is like a common code ownership. If we look here at how we make the lack of cooperation harder, think about the Kanban system or limiting the work in progress, right? If you limit the work in progress, then you force people to collaborate. Either they don't want to, they still have to, right? Again, when we've been to Toyota factory, they have a warehouse, and in this warehouse they have a nice visualization of what they have in the warehouse. The visualization was basically a plastic, like a transparent plastic, and you have a rows for different types of engines because they were producing engines. Surprise! So you get a rows for different types of engine. When you add new engine into this warehouse, you take the small like a small box, small brick, and you go to this board and you put this on the top of the board, so we know how many engines we have in the system, but we also know where we have those systems because each of these bricks has a number where it's located in the system, right? Now, you have two items here. You have so basically what you have a different types of engines, right? Now you have one line which basically says, well, if you cross this line, then we don't have enough engines, and we have a second line which says basically, if we go over this line, then we have too many engines. So that's the top, that's the max, that's the minimum, right? Now, what is interesting also in the system, which not always happen in Kanban system, is like the moment you want to take the engine from the factory, from the warehouse, you need to take the brick from the bottom of the system because of this board, because there is no other way to remove the bricks. So we remove the one that was in the system, the earliest, right? So the one that arrived a few days ago or a few weeks ago. And this is not only reducing the number of items in the system, but it's also giving them the chance to take from the system the items that are the longest in the system. Now, the last item, I'm going to mention this one because I'm running slowly all the time, is the concept of andon. And if you go to Toyota factory, then what we're going to see over every single person in the factory, you have a small rope, and then can basically pull the rope anytime they see the problem. Now, what is going to happen? We get a yellow light. If we have a yellow light over some employee, then the leader of this group need to go there directly and fix the problem, because if they don't fix it in like under 1 minute, the whole line is going to stop. Now, just to remind you, the idea in Ford system was never stop the line, never, the resource cannot be idle. And in Toyota, they were saying, hey, everyone in our system can stop the line. Like, we're not talking even about engineers. We're talking about the people who we just hire, who has the basic education, and they can stop the line. That was like a crazy idea, and this is still the craziest idea in most of the organization I've seen, right? So Toyota is saying anyone can stop the line. Ford was saying, hell, no one can stop the line. What is interesting is that when the Toyota started implementing this andon system in US, they figured out that the Toyota line, despite that anyone can stop it, stop less often than the Ford line, because anytime they stop the line, it's pretty expensive, by the way. It's like $100,000 for stopping the line for a minute or so. So that's not cheap. Anytime they stop the line, they need to fix the problem. So they need to cooperate. Like a Kanban is forcing them to cooperate closely on the problem, because if you don't solve the problem, then the line will be stopped. Now, the same idea is something I sometimes see in software development, not very often, but basically the idea is how you can stop the line, when you can stop the line, who is able to stop the line. Like, if you have a system and the tests are failing, are you going to turn off the test, which is common practice? Or are you going to stop the line and say, hey, no new software development till we fix the problem? This is the idea. And we got this idea coming in like, 15 years ago, when I used to work in Sabre, and we say, hey, if you have a problem and you cannot fix it yourself, then you show the red flag to the team, and we're going to solve the problem. And the next day, we're coming to the office, and basically there is an email from our team from US saying, hey guys, we cannot find the flag, but we find this nice red pattern in our kitchen, so we're sending this one to you because the testing environment is not working for us. So again, andon, when it's well done, andon is a system that can help you cooperate, can help stop the whole team and fix the problem in the situation. Again, it depends on the context. You can apply those ideas. You can apply those systems into the software development. So, just to wrap up. First of all, don't copy the techniques from Toyota just because they're from Toyota. Second of all, think about the consequences of like how we can, why they're doing this in Toyota, how we can transfer this into the software development. And last but not least, don't look at the resource utilization because that's basically a bad idea. You're going to have a plenty of waste created by this one. Thank you very much.
Thanks, Tomek. Question. Okay, so any other important things that we should know about the lean that we should pay attention when we thinking about using those practices?
Yeah, so one thing that comes to me, and why it's often difficult to move those ideas into software development, there are two items which are not so easy in software like in hardware. First of all, we don't see those batches. We don't see those work in progress. I mean, if you go to factory and you see a pile of doors, a pile of items, then you know that you have a problem. In software development, they just disappear. You have your Gojira, and you can put a lot of things into that, and your system is going to accept everything. A friend of mine is saying, Jira, the place the story goes to die, right? So you can put anything into your system. So first of all, visualize a simple visualization. As you might notice, I do prefer the physical visualization than the electronic one. You can do even the slideshow. On the paper. So do this simple. Do this make it owned by the team rather than having a fancy system and you have a Jira administrator to solve your problem. And the second item is like the batches. Again, if you see like 5 doors, then you know that the batch is 5. If you see 100 doors, then you know that the batch is 100. In software development, we don't see it. I mean, you can have a huge feature and say, hey, that's a huge feature, it's a 1. So we're focusing on one item. But in fact, you can split this item into many small items. So if you think about the projects, if you think about yearly budgeting, if you think about any big changes into the system, this is most likely what you can change. And I hope that the gentleman, a lady from the Falcon V system will mention something they were working on, which was basically, you were calling this merge festival that was happening at the end of every iteration. So all the teams were trying to integrate at the same time, and surprise, sometimes it wasn't working. Most cases it wasn't working. So what you discover, the batch can be also the size of the code you're integrating. If you're integrating 5 lines of code every few minutes, that's a difference if you're integrating 10,000 lines of code every 3 months. That's also a huge batch.
Thank you.